I'm sick and tired of seeing these useless gimmicks everywhere. Why do they even own a 3D printer? If you feel this way, it's time to accept that 3D printing is going mainstream, bringing in casual users who shouldn't be judged. Today I'll show you what your printer was actually made for. Recently, I found my dad's old film camera, the one that captured baby Salveo. I want to dust off its beautiful lens and put it back to work on my Sony. To do this, I need an adapter. I could buy one and have it delivered by tomorrow. But what happens when you can't just buy the solution? Do you just give up? Let's train that muscle together. We'll take this from a prototype all the way up to ordering an industrially manufactured metal part. There's one thing that controls everything in this build: the flange distance, the precise gap between the lens and the sensor. For old film lenses, this distance is usually greater than on modern cameras. We have a gap to fill and two completely different mounts to connect. We'll see later what happens when you go too long. I'll split the design into 5 parts. Let's start with the easiest. A donor bayonet is vastly superior to anything I could print. It's metal, and I don't have to waste time reverse engineering it. With this small test print, we can quickly confirm the fit on the camera. For the Fujica lens mount, we're not using a donor lens, but a donor camera directly. I really don't want to dismantle my dad's camera, so I bought this body for scrap parts. We're basically going to extract the bayonet and transplant it into our adapter. Going hybrid saves modeling time, the metal parts already work, and there's no reason to reinvent them. One straight top-down picture is enough to get a perfect reference of the bayonet housing. I then import the picture into Fusion, scale it using a known circular reference, and model straight over it. I run a quick test print to confirm the fit and to see if the original hardware plays nicely with the new design. And it's already working, but we are missing a crucial part: the locking pin. This small spring-loaded pin is what locks the rotation of the lens and gives that satisfying click. Getting to the underlying components means disassembling the camera body further. A couple of hidden screws later, the bayonet module is separated to reveal the leaf spring. Once again, it's a matter of taking a picture of the spring, scaling it and remodeling it. I'll reuse the internal hardware but redesign the external button. The result is an independent component that integrates the old camera hardware and behaves precisely like the original. We now have a fully functional prototype. Remember the flange distance? Let's mess with it and see what happens. With this long contraption, we completely lose infinity focus, and the lens becomes a macro. But that's an extreme case. Even a fraction of a millimeter of error throws off the focus. The FDM prototype works great, but I really wanted to give this tool an industrial finish, and this is where PCBWay came in. I went with CNC'd aluminium 7075, clear anodized, with a fine machine finish for the industrial look I wanted. The pin, button and leaf spring get mounted in place using precision tapped threads. An extra component was needed for the final version: a cover for the internal parts. It hides the internal hardware and prevents light from bouncing off the shiny metal. Because this cover needs precise alignment, I designed a Pokayoke feature so it only goes in one way. Finally, the Sony mount secures everything together and the Fujica bayonet is screwed into place. The cover features a small bump that pushes this latch, allowing for diaphragm control. Otherwise, it will stay fully open always. We now have a really solid, light-proof CNC machined adapter. But the real question is, was it worth it? Let's mount it on the Sony, hit record and find out. is the upgrade this channel needed, and a perfect way to bring new life to a lens that captured my first steps.